Easy root motion for Unity 3D. Why is root motion cool? When a programmer creates the character move, he may let them move faster than the animation. Or he may let the character move slower than the animation. The main idea of this asset is to allow the artist to create the character's movement, and get the right movement for the animation. The main features of this asset are: you can control the root move algorithm. It can be used with animations created with mockup assisted data. It also works with MIXAMO animations. You can move characters inside the update or LateUpdate method, without move flickering due to fixed update. It is possible to integrate with NavMesh to control AI agents. Let's start with a practical example using the MIXAMO website. Create a new project. Let's call it Root Motion Test. Now that the project is created, we can install the asset. The package has three main folders: Demonstration Scenes and Assets, the Documentation, and the Plugin folder. In our case we will use the demo script, so we need to import it. Import. Now that we have all our project folders, in the plugins folder we have the main components of this asset: Animation Motion, Root Motion Processor, and the Enhanced. Let's get some characters and animations from the site. First I will choose a character. Now we can choose some animations. Let's search for an idle animation. Click Download. The first time we get a 3D model, we need to select the collider format. With that format we can get the textures of the model. Select Unity format. Download. Now we can search for a walking animation. Download. Unity format. Download. Finally, we can search for a run animation. This is good. Download. Unity format. Download. In our download folder, we can extract the collider zip file and load the textures into the Unity project. Let's create an external model folder here. And import the textures. Now we can import all Unity models. I'm going to set the animation loop time parameter for all animations. From this point, we can work with Unity only. I'm going to create an animator controller for these animations. One state for each animation. We will use a state parameter to control the transitions. This will be animation 0, animation 1, and the animation 2. Let's create the transitions. Our transitions setup is complete. We can now turn off the exit time, so that the transition can occur at any time. Now our animator controller is ready. I'm going to use the demo scene with the third-person controller. I'm going to remove the current component configuration, so we can configure our components. Let's import the 3D model into the player controller. The player has a rigid body, so we need to create the collider. I'm going to create the root motion processor component. This will create the animator for us. Now we drag the animator we created, and click the Process All Animator Clips button. The component will analyze the animator's states, and show us a log. We need to set the animator in the third-person player controller component. Add the animation motion component, and click Query Clip Motion Influence Names. Now the animation movement has all the necessary information to move the character. We can adjust how each animation state influences the character's movement from this component. We need to configure our camera by setting the player forward reference. I'm going to put the game camera at the bottom of the screen, so we can set the player's position according to the camera view. Let's position it at the left of the screen. And we finished. Let's test. Walking forward. Running. This asset comes with a bonus. It has a custom motion implementation of the physics, transformation, and vector 3 move methods. This is what we got with naive motion algorithms. Unity Physics updates the position at different times, related to the update or late update methods. And this is the result we got when we used the bonus movement algorithms that come with this asset. They're not perfect, but they reduce flickering considerably. And finally, NavMesh integration. When you have the AI agent move state machine implemented, you can use it with the data from NavMesh. The result we got, each character moving according to each animation it has. Thank you for watching.